Contrast Security secures the code that global business relies on. It is the industry's most modern and comprehensive code security platform, removing security roadblock inefficiencies and empowering enterprise developers to write and release secure application code faster. The Contrast platform automatically detects vulnerabilities while developers write code, eliminates false positives, and provides how-to-fix guidance for easy and fast vulnerability remediation. Learn more about the Contrast platform at securityweekly.com/contrast security. The shift to remote and hybrid work over the past 2 years has accelerated application development on cloud infrastructure. However, securing these new assets has lagged behind. Qualys CloudView, the next generation cloud security posture management, delivers an end-to-end multi-cloud security and compliance solution encompassing the entire application lifecycle from build to runtime. CloudView enables enterprises to assess their cloud security and compliance posture, identify risks and gaps, auto-remediate issues, proactively enforce best practices, and prove compliance in audits rapidly and efficiently. Identify your most vulnerable cloud assets by visiting securityweekly.com/Qualys. Businesses need API protection that goes beyond signature matching and can stay ahead of attackers and their various tactics and tools. They need a solution that is more patient and prepared than a modern attacker and can track their actions over time. ThreatX is the only API attack protection platform that delivers on the promise of stopping API attacks in real time while giving you the visibility you need to prepare for future attacks. To learn more, visit securityweekly.com/ThreatX. Welcome back to Application Security Weekly. We just talked with Chen Gore-Eri from Enzo Security about why AppSec teams need to focus on asset inventories and frameworks to keep up with agile development teams. I'm your host, Mike Shima. I'm here with John Kinsella, and it's just about time for the news. First, don't miss any of your favorite Security Weekly content. Visit securityweekly.com/subscribe to subscribe to any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, Discord server, and follow us on social media and our streaming platforms. Plus, do you have a specific guest or topic, or lots of topics that you want us to cover on one of the shows? Submit your suggestions at securityweekly.com/guests. We review suggestions monthly, and we'll reach out to you once reviewed. John, I think AppSec map was pretty fun. That was definitely a hex crawl. I'm not sure if you failed your survival check or not and got lost in that, but glad we have you here to adventure with us through the news.
I definitely got lost in it, but yeah, I think it's a fun tool to play with.
Well, there's also some fun. I think we can. I'm not sure if we can tie. Let's see if we can tie a bunch of our news back to that. For me, there's a theme of a lot of little vulnerabilities that were that were popping up. That I wanted to talk about the individual vulns as we often do, but tie them to more to broader aspects of application security, if you will. And as a first example, there is a authentication bypass bug in nextauth.js that could allow an account takeover by emails. And what was interesting for this is that it's an email parsing problem, which was really, really fun because you could, as an attacker, you could send a comma delimited list of 2 emails, for example, to an endpoint. The endpoint would say, oh, cool, I have 2 emails to send this magic authentication link to. And then another step in that, when you come in to log in with that, it would basically just do the parsing would say, we're going to split on the @ symbol. And so if you have your attacker domain listed last, you come in as the attacker domain and you're authenticated. So it's one of those dead simple to overuse that phrase, but both in how it can be attacked as well as what the parsing looks like. And so I thought that was kind of fun just because it fits into the idea of parsing is rife with errors. And this is a parsing problem that's logic, not a memory safety.
Yeah. And I mean, yeah, I think this one we can call it dead simple since they gave it a CVSS 9.1. Yeah, it's funny because the actual article about itself is like, fits on one screen. It compares some of the stuff we've got to go through, which is pretty meaty. It's like almost gets the shrug emoji, but at the same time, It's like it's CVSS 9. It's super important. It's super critical. I'm not personally sure how widespread this is in use in JavaScript and TypeScript web apps. So I'm not sure how sort of out there it is, how many downloads, how many people are really dependent upon it. But yeah, man, this stuff, you're spot on when you sort of how you led into this. We've got a few articles today talking about both either simple-ish vulnerabilities or really how the state of these type of things exist and why. And like, it's like, oh, it's another parsing thing, or I won't foreshadow too much, but we've got a few more of these and other X things. And the question comes back to like, how do we as developers make these become a little bit more secure? And yeah, it's difficult to do. So I don't know. I'll continue that conversation as we continue through the stories. How about that?
Yeah, we'll get there quickly, I think. So we're high on the initiative list. Don't worry, because the other thing I wanted to mention there on the email addresses is the idea of normalize your data, then apply the security decision. So why did this endpoint get a string and treat it as two email addresses in this one context, but then in this other context, treat it as a single email address? I had another article that honestly kind of gets a shrug, to use your language, for a parsing error in URL parsing in Go. So, mishandling a semicolon, there's actually just parsing correctly perhaps, but ignoring an error when a semicolon shows up. So one of those examples that I just like to harp on, just to say, I love the fact that we have Rustaceans out there and languages like Go because they're memory safe, but memory safety addresses only one of the vuln classes out there. So parsing is another big one. So normalize, then parse, normalize, apply security decisions. I think the same could be said. I'm going to burn through these real quick, possibly for some path traversal, because you were very kind to pull out a path traversal bug for me. So I missed that one. Tell me a little bit more about that.
So that was on top of your one. I want to go back to Go for a tiny second, because this one started as a oh shoot, stop everything I'm doing and go look at it, because I'm Go is sort of my world, not completely, but for a good chunk. And then as you look at this, it's like, oh, I'm not doing any things they're talking about, or that's handled by something else. So it became a shrug. But this, and if memory serves me right, one of the other stories we're talking about, I forget, so I could be wrong this week, but this became, I believe this came out in, let me look real quick, net URL library prior to 1.17. I thought this had been introduced in 1.16, so I could be mistaken, but I'll still harp on the point, which is sometimes when we add functionality, we're actually, we forget to do a check, or we forget to do one little thing, and we think we've got stuff right, either for the time of day when we're writing it or whatever else have you. And that's when, it's funny, right? Because I'm not trying to justify what I say on here, but we frequently talk about, I don't want to refactor code, or I don't want to do changes, not just because it's like business, I got better things to do, but right. Even if you change that thing and you think you're perfect, there's still a chance to make a bug, but this isn't that. So I'm talking for no point. And you wanted to go over to we have a pair actually of path traversals. So the first one, which you mentioned, RS routers, which isn't that Motorola, if I remember right? Anyways, they've got a vuln there. There's a few things in here. There's a null pointer dereference. There's a buffer overflow on URL sanitization. RS modems used by AT&T. But yeah, it's it's when I see the phrase path traversal, I think of you, Mike, and I have to add them into our story. So we had one in here with there is a web server on this device, as there is on many nowadays, and the path traversal in there. / as they have to actually type out, allows you to go and see different parts of what's going on that device and see files which are stored outside the root of the web directory on there. It didn't look... You can see some other things. You can see encrypted files. I mean, it's sort of standard for a web server from the last 10 years. When we have a path traversal of vulnerability on it. Excuse me. Yeah, so this looks like something we've seen on WRT54s before. We've probably seen it on versions of Apache and PHP and God knows whatever many other things out there. And here we are again. So, as we're saying, a lot of the things we're going to be talking about today comes down to how do we sanitize that input? And can we find a library to do this? Can we, so that's I'll leave it there for right now. I'll tease these out through the next half hour. I don't know, Mike, there was another path traversal in there that you found. I don't know if you wanted to hit that one maybe.
Yeah, I think part of it too is the idea of I dislike jumping into security discussions, security recommendations to say input validation, and input validation protects us from all things, because input validation, I'm going to say, isn't really a problem with cross-site scripting. Cross-site scripting is an output encoding issue. SQL injection isn't an input validation issue if you're using prepared statements. It's a separation of code and data. And even with directory traversals, path traversals, obviously one of my favorites, dot dot slash, it's very much a normalization issue, of course, much like dealing with emails or dealing with URLs for that matter. But with path traversal, it also brings up, why are we accessing the file system in the first place? That just sounds like a sketchy design pattern. Even if we're trying to read from the file system, let alone being able to, in this case, delete from the file system in this complete FTP path traversal flaw, this article that I pulled up. So it's one of those aspects of, yes, I would love to talk about path traversal, but maybe the smarter discussion, the more effective discussion is, how come we're not using a small SQLite database to hold these little objects, or dropping them into an S3 bucket or some type of storage like that? Because I just don't know why we need something that is prone to or that needs this type of traversal of directories in the first place.
So for an FTP, that's sort of, I want to say it's a given, right? Because you're correct.
Fair
you could
point.
be getting from S3 instead, but it's a file server.
Yeah.
But let's talk about that for a second, because I think it's interesting. And I will, with my loose vocabulary, will frequently say sanitization versus here we go. Actually decoding and how are you dealing with input sanitization or actually encoding the response back to the user? So I get what you're saying there, but in my head, the reason they're too similar, the reason they're sort of stuck together, is because either way, that's at the point where you're dealing with something which you don't trust, right? So it's whether it's coming from someone, or whether it's coming from a user, or if it's coming from maybe a third-party database or an API call or somewhere else you've gotten, and you've now got this thing and you have to either store it securely or display it securely, which is sort of the two things we're thinking about. In either way, back quickly on the mail one, I'm sure we've mentioned this before in the past. If you go back to the O'Reilly regex book, they've got in the back, where I'm going, there's the regex for an email address. Man, guys, if you haven't seen it, go Google around. I don't have the URL on it. It's probably 20 lines long, like the width of a O'Reilly page. So it's got to be over 1K in length, if not 2K. So these things are not simple to do if you're going to try and do it yourself. Dot dot slash sounds funny, but how do you actually go about encoding that? Or how do you go about making that safe and sanitized? Okay, yeah, you can filter out a dot, but then, okay, what if they start doing character encoding? Okay, they have to do that after you do that. So it becomes a little more difficult. And then how do you do that with an FTP server? Maybe they were thinking originally this code will only be used. Maybe they used a library for sanitization on a web server, and someone came along and used it in an FTP server. So there's all sorts of edge cases, or maybe they just didn't know or care. And we all need to be educated at some point. So that's is what it is. But I don't know. We've harped on that one enough for today. Where do you want to go next?
I want to go. Let's stick with sort of these design decisions, and you're doing a great job of educating us on these topics. And I'm going to hit the Slack bug that exposed some users' hashed passwords for 5 years. That's the Wired headline that I took this article from. And once again, we could talk about password hashing schemes, but in a way, I want to skip over all of those aspects of choosing passwords and password management and scrypt versus bcrypt, and say, why does a service have access to the hashed passwords in the first place? That to me seems like the fundamental design issue here, the architecture problem. Because if a hashed password can leave the system, that sounds like a major design flaw. So I see you smiling, John. Let me
It
pause there and
it's
see where you'd like to take us on this adventure.
oh hey, my battery finally died. It's sort of the way you know, Slack is sort of the modern version of IRC, or some of us call it that. Maybe it's sort of this way of getting a hash password is sort of the modern version of a directory traversal. Sorry.
No, I like it.
So completely agree with you, and that's sort of the, again, when you think about coding this type of stuff, it really does often come down to how do you, what's that thought process? Sort of comes back to, we also talk a lot on here about, you know, thinking about what are the threats we're dealing with and how do we actually either tabletop them or think them out or model them, or how do we want to deal with it. This is sort of a version of that. Is like, okay, well, when someone was coding that, they're thinking, okay, it's Slack. So the first version is we're IRC. So we're going to send text back and forth. And then someone said, hey, let's add emoji. And then someone said, hey, let's add the ability to send and receive files. That'd be sort of cool. Then someone else said, hey, might be sort of useful to be able to do, well, maybe not useful, let's be honest. They probably said, hey, we want to put video chat in here so we can compete against Zoom. And the next thing you know, you've got what started as probably, a few thousand lines of code is this big behemoth thing, which, a very large chunk of organizations in the planet are using. And did they go back and actually think about how to do the little tiny, not allow passwords to be, I mean, even in the first version of this, that shouldn't be possible, but I'm sort of thinking through how did that actually grow in a analog way, I guess, is what I'm thinking. And it might have just been bad in the first place, but I'm guessing it was sort of several things led up to it. And then we ended up with this sort of nasty thing in the end.
Yeah, it's interesting to riff a bit on the intro. The evolution of a code base is interesting to watch, especially as this was, this flaw existed for 5 years before it was noticed. And you were touching on a couple of the technologies brought into fancy IRC, aka Slack. And I think I didn't have a link for it. I do have to, but in some of the research that I was reading about this, I thought this actually came from a particular use of WebSockets that was part of the code base here, part of the tech stack that was responsible for leaking this, just how the WebSockets was being used. So it was kind of interesting to see what pops across the radar about maybe 5 years ago. WebSockets is really cool, and this is what happens. And then things just get lost in the chaos as the attack surface of your application grows.
And you know what that makes me think of is GraphQL. Because this is probably frequently one of my fears with GraphQL. One of my co-founders is trying to get us to use it. And I'm not saying no, but I want to do the timing right on it. But part of the concern for me is those transformers that you put in there to actually, you don't just add GraphQL to a project. You don't just add WebSockets, right? These are fairly powerful things depending on how you implement them. And if the architecture and design of that isn't right, the next thing I could be allowing someone to, write GraphQL queries to take data from my backend that never intended to go out to the public, right? Or to a customer, whatever have you. And it's sort of that same thing here, probably in a way, is, okay, you added a WebSockets. Have they thought about, I mean, I'm partially being facetious, but still, did they actually think about path traversal on that WebSocket? Because it, again, probably is something slightly similar in there. And yeah, how do you do that? And, we're trying to go quickly. And it's funny for folks who haven't looked at code recently, for the all those non-technical people listening to the show, what you would think would be like, oh, I need to get something from a database. Like you write a select statement, you put it into a struct, you return it, have a nice day, go back to business. But like that code will be there and it'll be like 4 or 5 lines. And then there's about 30, 40 lines around it, sort of making sure, okay, did we do the right thing? Is this going on? And so, and that's,
am I authorized? Again, yeah, exactly.
Part of this, right? It's people get either tired of writing that code, or it makes your code look ugly, or there's all sorts of different reasons. Even I myself, I'm like, I just want the 4 or 5 lines. Okay, how can I hide? Can I put the rest in another function and call it? Or what can I do to make this clean and neat? And that's probably part of what you run into with some of these things is people getting, I don't want to say tired of it, but sort of tired of it.
I think there is. I agree with you. I think there's a call it like the mental overload, the mental overhead of just trying to keep this, keep the authentication state or the authorization state. I mean, of a GraphQL in your mind, or trying to understand it in just one screen size of code. Once you have to scroll off your screen, it does get harder to keep in mind, to reason through. Another thing that comes to mind as you're describing that, we started off about some parsing issues, parsing email addresses, parsing URLs, path traversals. Those lend themselves, I want to say, pretty well to fuzzing or to unit testing or functional testing, so that as we do, as I encourage our teams to go and refactor their code and keep it up to, but these changes that happen can ideally be caught. But I don't know that GraphQL and the authorization checks on these data, like can I pull out a password hash, lends itself as easily to fuzzing, because that knowledge, that context of, oh, I wasn't supposed to get access to this piece of data, I think is a little bit hard. It doesn't cause necessarily a crash. And so I'm kind of thinking out loud here why this situation in GraphQL, that type of scenario, may be even harder for developers to think through.
And that's part of, as you add these really briefly, as you move into these new technologies, it's not just how do we use them and how do we make, oh my God, let's go let the UI person's life be so much easier. How do you test that, right? And that's frequently, I think, either if you're doing test-driven development or even just, the QA guy or a girl or anybody in this path is like, once you've got this thing or you're thinking about creating this thing, how do you test it to make sure that thing does, what you're expecting it to do? And that can be fairly difficult.
It can be difficult, and that we're sort of leading into one of your articles about why security is so hard in 2022. I suppose we could put any year in there, but John, do you want to hit that, or should we hit a couple more of these individual interesting bugs that you've hit, as well as we continue to build up examples of why security is so hard?
Sure. Let's tease the audience a little bit longer. Well, we have one. So I think, we've talked a few times this year about post-quantum encryption. Ooh, it's my new jazz hands. I can't talk about machine learning that much now. Just jazz hands this. And so the TLDR is someone took one of those 4 encryption algorithms, which I believe DoD, or was it NIST was having a ponder about making a standard, and they broke that bad boy in a single core PC in 60 minutes. So yeah, and the reason I put this in here, beside just the aspect of it, is that that's sort of at least to me, again, it's reason of why you don't roll your own crypto, right? Not alone, definitely don't roll your own post-quantum encryption. Right. God help us. But even just the basic standard stuff for us, us plebes with our just our simple computers. And it's triggering something in my head. Last week or two, I saw someone writing code that they shouldn't be writing. And so that made me think of this and made me think of that. And yeah, we don't have to dive into this too quickly. There's a little bit of math in there, and you can think about why or what happened. And but at the end of the day, is like if the experts who are actually getting an algorithm to the final 4 of NIST are still getting popped that quickly by a PC, not alone a quantum box. Don't leave it to the experts, I guess, is sort of the thing there. And I guess to bring it back to the rest of this is like, why don't we leave a lot of the rest of this to the experts? That's what I'd sort of love to see. Where's Application Security Weekly in 5 years, right? We shouldn't be on the air. We should all this stuff should just be done and people should be listening to us. But we know that's not going to happen. So, yeah.
Yeah, well, this is why I'm setting the seed so we can talk about Dungeons and Dragons and Synthwave. So in 5 years, we can move out of AppSec because all the defaults are secure and all the configurations are deployed by default, which I suppose is actually redundant what I just said there. But that's why we have you to save me. So maybe we could talk about there's another email routing issue that was kind of interesting, a rootkit. Or should we talk about why security is so hard? Take the lead here, John.
I like the rootkit because it's meaty in my previous neck of woods. So 2 companies. There's 2 versions of this write-up out there. This one is done by BlackBerry and Interzer. Go take a stab at that name. I hope I'm pronouncing it right. I'm guessing they're Brazilian because this sample was found down in South America. It's a rootkit. That these guys went in, have a pretty good blog, actually, sort of reversing and talking through what's going on. But really, sort of what caught my attention up top on it, not the top, but in there, is if for those of us who've done IR or maybe even have written some of this stuff, when you are doing rootkits, either trying to find it or detect it or write it, you're trying to. It's very cat and mouse, right? The goal. One of the core goals of this is how do you hide yourself either from a someone trying to track down if there's a problem with the box or antivirus. So what these guys did is, usually you do things like if your program's running and someone does PS on a Linux box, you make sure your program doesn't show up. Or if you do a list on a directory and your binaries or your data files are in there and someone does ls, it doesn't show the files, right? That's some sort of base level setting. What these guys have done on top of those type of things is they have also hooked into the Berkeley packet filter, which is the core tool, at least for 10, 15 years, Mike, in the Linux kernel, which is how we do packet sniffing, TCP dump or firewalling or all sorts of different things. But so what they did here is they want to be able to phone home and send their data off the box without people knowing what's going on. So they've actually hooked into BPF. So if you're on that box and you run a TCP dump and start trying to look for that data, it filters it out, which I thought was very, very cute. And that's sort of the part that, you usually one way or another with this cat and mouse game, when you get on a box, it's, do I know Linux better than the person was expecting someone to know when they were doing IR on this box? So do I have tricks on how to either find files or network devices or, something running in memory? Do I know ways around that Linux system at a CLI or with programs, whatever else, that I can find something that they didn't think about hiding from or they were too lazy from? So, frequently you might want to do a TCP dump and actually go and see, hey, what's going on over the network? Is there something going that I don't see? And the fact that they thought about blocking that, I thought was sort of cute. And then one other thought before I will stop, figure one on here, I thought was sort of, figure has to catch my attention. But they have a graph showing the different type of evasion techniques they're doing. So, like I mentioned, list running processes, TCP sockets. We talked about UDP packet capture. They're doing TCP and UDP. List directory contents, and then also listing for shared object dependencies. So one of the things you'll do frequently is run LDD to see what other objects a binary is linked to or shared objects. So they sort of showed these are the evasion. These are the targets that they're trying to evade from, and then some of the tricks that they're doing to do it. And then the rest of the article sort of diving down into that at a machine code level or talking about some of the stuff in detail. So it's a fun read, I thought. But then again, like I said, that's sort of partially my wheelhouse from previous lives.
Yeah, absolutely a fun read. I think to me, what comes to mind is the idea of, it speaks to the dimension of observability, visibility into networks that we touch on occasionally, but maybe not enough. Just in the sense of this is an area of maturity. This is an area where cloud perhaps can be more helpful in the sense of net flows are your friend, especially if you're getting net flows off the system that isn't backdoored by this BPF hooking. So you can see, you can identify where this malicious or sketchy or just strange type of traffic is coming from, to use a bunch of thesauri words. So we're going to keep with the anticipation of security is so hard. I'm going to pull in two other articles, I think, to set that up. And I pulled in an article about a school kid uploads ransomware scripts to PyPy as a fun project. And I had another link in there about a researcher who threw thousands of malicious projects onto GitHub. And I was, again, kind of less interested in what the specifics were of these particular events, attacks, and more about the idea of why, when we talk about threat modeling, I care less about who the actor is in terms of this is an APT. This is an equation group that can create a BPF hooking to hide their activity within their implants. Or this is just a school kid that's uploading a bunch of malicious projects to GitHub or PyPy, for example, because it's more of what are the consequences? What do I care about? Do I have cloned repositories that people are going to accidentally pull down, and now we get into my supply chain issues, things like that. So those are sort of kind of building my case for focusing on consequences rather than focusing on the actors themselves.
My first thought was give that kid a job for the PyPy uploads. But yeah, and the second thought here is, I want to go back and look at some of these a little closer. So I get what they're doing. They're typoing. They're frequently squatting on name typos. This quote unquote kid, one of his packages was downloaded 258 times, which doesn't sound like a lot, but I'm pretty sure I've got something on PyPy that hasn't been downloaded 258 times. And it becomes a bit of a psychological and a marketing thing to me. It's like, okay, how did he actually, is he getting lucky, or is he, without going to heavy malicious effort, is he coming up with unique or creative names that are something which is interesting enough for people to sort of go, I'm going to add that to my Python code. Let me do a pip install. And that to me is sort of interesting, right? Is how difficult is this actually to, you don't have to be that top guy who has the most, who either takes over domain and gets your package out there and has 10 million times downloads. But if you can do, a few hundred downloads, that's probably, you're going to benefit from that one way or another. How about that phrase? And I think that was sort of part of what was interesting about this to me. It says there's an absence of malice on both of these we're talking about. Is it really that absent when you're causing that much trouble? And I heard about the GitHub one. I didn't dig into it deeply, to be honest, but it seemed like there was a lot of drama about it. But that in either case, yeah, it's a fun thing for someone to play with. And I guess this also comes back a little bit, Mike, to that article we covered 3 weeks ago, I think it was, talking about there was a intern at a security company who has part of, yes. Remember? Yeah, he was, for those who haven't listened to all our episodes, there was an intern at a security company who was purposely uploading malicious packages to PyPy, trying to get one of their target customers to download, to see if their come on, Brian, to see if their ability to do
red team exercise,
not code signing, but yeah, thank you. If that was actually, if they had their stuff in place. So how do you use these things how do you use these public resources in a way that doesn't that allows you to do some sort of security research on them, but isn't really causing pain for people? Because 258, again, that's not a huge number, but the other one actually, I believe, was malicious or had potential to be malicious. So what actually is, and how do you do that in a safe manner, I think is something we need to keep talking about as an industry.
Yeah, and I think this week is also DEF CON Black Hat. So there's a bunch of presentations that we're going to, once they're over and done with, that we'll go watch and summarize here on ASW. One of them would be around bug bounties, for example. And there's an aspect here of malicious or not. There was a lot of time spent to figure out, was this malicious, or to clean up, or were we impacted by non-malicious activity? Or even, for example, in that red team exercise, were we impacted by a typo squatting or an unsigned package that we downloaded? That time spent is money that comes out of a security budget. So it's also that aspect of how can we do this research that's still friendly to organizations that need to respond to this, or how can we learn in a way that isn't building unfortunate relationships with the security community because you're taking up a lot of their time. So those were just two areas that maybe I'll just throw out as a call to listeners. What are some other learning resources or learning techniques that you've enjoyed that can be done in a bit, call it a safer or friendlier manner in these areas? And John, I'm going to pull in one last article of mine about the Twitter just in the spirit of yet another bug that came through a platform, an update to the platform's code in June 2021, is what they say. And this was identified in January of 2022, I believe, through HackerOne, saying that an unauthenticated user could still discover on an Android client whether or not a phone number or email belongs to a particular Twitter handle. So it was basically an oracle saying, how does this map to, who does this tie to? Goes back to a little bit of a theme, of course, 5-year-old code. In this case, it was maybe a less 6-month-old code where it showed up, but the vulnerability existed for quite a while before it was found. And I think this is one of those reasons that makes things hard. So that's the setup to you to either tell us a bit more about your take here on Twitter, or a Twitter thread about the difficulty of security.
So I think this is year one to start with is a fun Twitter thread. Just sort of, threads are interesting for people. They're very quick to read, but as me and my day hat on, my day job hat on, frequently putting these threads together takes someone a lot of work. You're looking at frequently, possibly hours, like something like this. So their little 12 post Twitter thread, easier for me to say, there's actually a pretty good amount of work behind it, right? So I think that's sort of not interesting by itself, but just the fact that this is another of many our ongoing year of the security problems with cryptos. And it seems more people are talking about it and recognizing it, even outside of the security industry, or I should say community. So the question is, what do we start doing? There was all sorts of problems with Solana. What was that last week? I think so. So lots of people are losing money in these things in different ways. And hopefully, not just with the tanking of the crypto coins, but the security aspects. So hopefully people will start making these a little more secure. But with that, I will jump over to another Twitter thread, which I just found this morning. So this is written by Eric Bernhardson, who was he used to be ran engineering at Better. He wrote the music recommendation system over at Spotify. So the dude's sort of been around the block a few times. And, as a media organization, we're not here to do the standard media organization thing of read tweets to you. But his question, which he posted yesterday, serious, not troll question. Why is security so hard in 2022? We should have solid battle-tested ways of doing most things and sensible defaults built into frameworks. Instead, we rely on developers to be vigilant. And then I don't know how many responses. Well, I guess... I'm not sure many responses in here, but there's quite a few. But what's interesting about this is, so it seems like where he sits in the world and what he's working on now, he's sort of working at a data science company. A lot of his followers I'm guessing, are the sort of machine learning data science types. So the responses to that question are not completely. There's some security folks have jumped in, but I'd say 95% are either developers or more likely data people. So I thought this is a very interesting thread to see. How do people outside of our little bubble in 2022 think about AppSec? And the response, or at least the result for me from reading through this morning, was a little bit of all over the place. There was one guy saying that, injection is still impossible to prevent in 2022. And I'm like, no, not really, dude. At least most of it can be prevented. Some folks saying, hey, the government is, they want themselves to be secure, but they want everyone else to not be secure. So we're getting a little bit of sort of fringe thought in there. There's a good thread to go through. It's in the show notes. Just sort of as I scan through here now, there's some sort of productivity cost, and people want to get features out, or who actually cares about security. So there's really this very wonderful bouquet of different thoughts and opinions in here. But for the people who are, it could be frustrating. I should probably trigger warning it for some of y'all. For those of us who actually work on AppSec day in, day out, and we're trying to do the right thing, some of the stuff you see in here, one just popped to my attention, people are much more concerned with DX, that's developer experience for those who aren't the kids out there. Performance features, security is just assumed and then becomes an afterthought. And I mean, I'm not saying any of these are wrong. It's a very interesting spectrum of thoughts and viewpoints from the people we're trying to help. So either we're not getting the help out there, or we're not making things as default secure as they should be, or sort of a bunch of different things. But I think it's definitely, whether you spend time on Twitter or not, it doesn't take too long to scroll through this and just sort of stop every now and then and either look at the funny memes which have been posted in this thread. Someone, one guy's wearing like a bulletproof jacket and gives someone a gun, and the guy shoots him in the leg, and says that's sort of what's going on in modern day security. But anyways, I think I like to try and get our audience to think about who we are, what we're doing, and Mike, this is another example of it. Is not just thinking by ourselves, but like take a step back. What do our users use, or what do our users do? We probably frequently in this show think about developers. We're not thinking about data science. I mean, okay, you could say a data scientist is a developer. I don't mean to segregate, but they're a little more focused still purely on how do I get that CSV into a Python object or a Python structure, not so much SQL injection and stuff like that. So I thought it was a very interesting thread of outside our little world, are we actually making a difference, or what do people think?
Yes, and getting outside our little world. I mentioned there's Hacker Summer Camp going on right now, but how many times have you, speaking generally, not just you, John, been to a developer conference and there's been a security track? Or how many times have we seen a talk from a developer conference that is touches on a security topic or points out one of those reasons why this is hard, when they're talking about, here are 45 minutes about how to harden your Kubernetes infrastructure, versus the one slide that says, deploy this secure default, and the next 44 minutes are about doing something much more interesting and exciting. So I think with that, we're going to take things out, and we're going to go let John go back to his Twitter feed to find some new and fun memes. And but I will say thank you for joining us, John. I'll say thank you everyone else for listening as well. Please do subscribe, hit that like button, check out the show notes. And speaking of synthwave, check out The Dark by Starfarer. We'll see you next week on Application Security Weekly.